Okay, so I have three more examples. Hopefully this goes by really, really quickly. Use the nth term test on the series and state its conclusion. So we'll look at this one first. All we have to do is take the limit as n approaches infinity of the sequence, which is 1 over 2n. Okay, and this goes to infinity, so this goes to 0. Right? The whole entire thing goes to 0. Now, remember, the nth term test for divergence says that if it doesn't go to 0, then we can conclude something. However, here, this does go to 0. It doesn't mean it necessarily converges. It just means we don't know. So when it says use the nth term test on the series and state its conclusion, you'd say no conclusion. And it's specifically from nth term test for divergence. We would have to use some other technique, just like U sub wouldn't work. We'd have to try maybe using some fancy antiderivative formula, or maybe partial fractions, or evaluating improper integrals, or whatever. All right, let's take a look at this one. Limit as n approaches infinity of 2 to the n. Well, of course, that goes to infinity, so that's definitely not 0. So we can say diverges. So cool, yeah, we're good. We're good. Wait a minute. The nth term test for divergence said that n had to start at 1, but you can play around with stuff. I don't think you have a problem like this, but let's see what we can do with this. First, I'm going to write out a few terms. This actually, if I plug in 0, I get 1. If I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in 3, I get 8. And then it just goes on and on and on forever, because I go to infinity. Well, I could remember that this is when n equals 0, n equals 1. I think this is super helpful. n equals 2, n equals 3, and so forth. So if I wanted to start this when n equaled 1, I could just say, let's start it when n equals 1, 2 to the n, plus 1, right? Because that's when n equals 0. So I can just shift it over. Now I can use the nth term test for divergence. I mean, if you used it on that, it wouldn't have made a problem anyway. But just to show you that you can mess around with this bottom index by writing out the sum first and then taking it, instead of from 0, you can start at 1, or you can add 3 and start at n equals 2. So it doesn't really matter. You can always play around with the bottom. So this definitely diverges still, because this goes to infinity. Like or actually this goes to infinity. So you're adding a bigger and bigger numbers each time. So it diverges. All right, cool, done.